All right, welcome back, everyone. So we are now going to talk a little bit about what expectation and variance looks like for a continuous random variable. And so I'm going to jump down a few pages all the way down to page 5. Um, and on page 5, we see right away that we have a formula for the expected value of y, where this time y is continuous and it has this density function f of y. So the formula says that we'll just integrate this function from negative infinity to infinity. I'll make a quick note here that we will usually simplify this. So usually, depending on how the density function is defined, we won't actually be integrating from negative infinity all the way up to infinity. There's usually a simplification, as we will see below. All of the rest of this is, so from here all the way down here to the definition of variance. These are just rules and things and definitions that are really just the same as what they were for discrete random variables. So we'll make a quick note of that here, that really these are the same discrete rules of expectation. So these same discrete rules of expectation, they also apply to continuous random variables. So that's great news, right? I mean, we've already learned all of these rules, and so we don't need to relearn like a completely different set of rules for continuous random variables. They're really just the same. Um, and really, just in general, for continuous random variables, often we're just replacing a sum with an integral. So for discrete, we add the summation symbol a lot. For continuous, we will often be integrating. Okay, so let's jump down then into this example where we have this density function, and that is 4y cubed on the interval 0 to 1, 0 elsewhere, and we are prompted to find the expected value of y and then the variance of y. And so let's start with the expected value. And I'm just going to copy down the form or the definition above. So we're integrating y times f of y with respect to y from negative infinity up to positive infinity. But you might notice that the definition of f of y changes depending on the value of y. And so we're seeing that in the support, that y is defined as 0, or f of y is defined as 0 on anywhere outside of the 0, 1 interval. And so we could split this up to accommodate that change in, or that difference of the definition of f of y. And what you'll notice is that the simplification that I alluded to earlier really is that these two parts drop out. So we really only have to worry about integrating f of y over its support that is positive. And so again, we don't have to worry about the 0 elsewhere when we go to integrate, and so that often simplifies the problem a little bit. And this is an easy enough integral that you can do it by hand if you wanted to. And so let's see, that would be for 4/5 y to the 5th, evaluated at 0, 1, gives you 4/5 as our expected value. We can do a similar thing to figure out the variance, and so we'll do that. I'll go through it more quickly, and I'll skip over the crossing out part like I did here. So usually you don't have to like write that out. We were just being explicit because it's our very first one. And so the variance of y is still going to be equal to this little shortcut formula that we used for discrete random variables. And so we could figure out what the expected value of y squared is first. Again, that's just going to be integrating y squared times 4y cubed with respect to y. And again, I'm omitting the negative infinity to 0 and 1 to infinity integrals because we know that those will be 0. And so again, you wind up with 4/6 times y to the 6th, evaluated from 0 to 1, which gives you 4/6 for the expected value of y squared. And plugging that into our good old variance formula, we've already figured out the mean of y, which was 4/5. And if you do that calculation, you wind up with 0.027. One last quick note. So there will be times, I think, where it's not really worth the time to do the integral by hand. And in those cases, I, in class, will use ChatGPT mainly for my my technology to integrate. And so I've already done this one just to save a little bit of my typing time. And so you could see my prompt up at the top. I just said integrate the function 4y to the 4th with respect to y from 0 to 1. ChatGPT, of course, doesn't shut up ever and gives me this super, super long thing, but the only thing I really care about is the 4/5 at the end. And I'll amend that statement. I do kind of care about the work because I would like to kind of quickly check it to make sure that it makes sense, which it does, and it gives us the same answer. And so you could also do this to find out the expected value of y squared, again, kind of using ChatGPT as a calculator.